As we've just recently done, the server is started. We can confirm the such using netstat ntlp grep squid. You'll see that it binds once we get the netstat command properly run to port 3128. So by default, squid binds to port 3128. Note squid defaults to TCP 3128. This becomes important when you configure your client, your web browser client, whether it be a text-based browser or a graphical browser. A text-based browser also includes wget. Many programs make use of proxy services, and in the case of Squid, be prepared to reference port 3128, although Squid can be certainly configured to listen to any port not currently in use by some other process on your machine. So this is Squid running on port 3128, and it's listening to all IP version 4 addresses, which means it's ready to accept connections. So our next task before we enable traffic to flow is to configure browser. We'll configure Firefox browser to use Squid proxy server. And that's a straightforward process. In Firefox, we'll simply navigate to where our options or preferences are located. Within Linux, it's Edit Preferences. Within Windows, it's Tools, Options. Both lead to the same general area. And once in that general area, we'll make the change to point to our proxy servers. There's a connection area, and you'll see a manual proxy configuration area. So after you've located in the General tab, determine how Firefox connects to the Internet, in the connection area, change from direct connection, which is the current layout, to manual proxy configuration. And once you've changed to manual proxy configuration, indicate the name or IP address of the proxy server. Let's start with the IP address, which is 192.168.75.199. The port isn't 0, of course, it's 3128. You may optionally use this proxy server for all protocols listed below. Squid supports proxying for the protocols listed. We'll click on OK, close, and now subsequent sessions, that is, out to the net, will make use of the proxy server. Now let's try to refresh access to 75100 to the server repository, and notice Squid is picked up, indicating that it could not retrieve the URL. Access is denied. This is the default configuration, and on the exam, if you do pursue certification, this will be the default installation, whether you install Squid or it's pre-installed for you. So your first task will be to allow general access out to the net from your local subnet. Our local subnet, if you recall, is listed above as 192.168.75.0/24. We want to indicate this subnet in the default Squid configuration file, and we do so using an ACL or access control list entry. Squid supports many such access control entries. So the fourth task is finally to configure Squid to allow LAN access through to resources for which Squid can serve. So to do so, we're going to modify, let's list as step A, nano etc squid.conf. This is the main config file which houses the ACLs. They can be split off, but this is where you'll find them by default. So let's navigate to that directory, then nano squid.conf. And in here we want to manipulate our ACL section. You can go ahead and do a search using Control W if you're following along in search of ACL, and you'll see different references to ACLs. But as you navigate throughout the directory, you begin to see uncommented ACL definitions. Items that begin with hash marks are commented items, whereas items that do not begin with hash marks are non-commented items. So we can include an ACL setting anywhere in the document. Just be sure that there are no deny settings currently defined. And there is in particular an access control section. Let's go ahead and Control W. Beneath the access control section, you'll find everything you need to know regarding how to define ACLs based on criteria supported by Squid. We should just note as well in its feature set that it supports a wide criteria of ACLs. For example, based on destination domain, source IP, time of day, etc. So you can build ACLs based on a wide criteria, tailoring your environment to suit your needs. So in this access control section, if we scroll down, you'll see where HTTP access is denied by default. You'll also see that it's heavily commented. You can block based on MAC addresses or allow based on MAC addresses, day of the week, the port that's being accessed, the site, the source, you name it. We cover a lot of these features in Linux CBT Proxy Edition featuring Squid. But for our intents and purposes here, in this edition of Linux CBT, we're going to enable LAN access. Now here are some rules that are uncommented, meaning they matter. This ACL all, source, all IP addresses, all subnet masks, is later referenced for HTTP access. So let's scroll down, and we see some safe ports that are defined. These are ports that can be serviced through Squid. Squid knows how to handle traffic to those ports, including your SSL, web, FTP, etc. But if we keep scrolling down, we'll see where the reference is made to deny all access by default. The default is HTTP access deny all, but this is not where it gets done. This is simply a commented area. Below, if we scroll down, we'll see that HTTP access is denied to all users, which is referenced by the ACL defined above, HTTP access all, or all ACLs. So here, HTTP access, meaning if you're accessing SSL or HTTP-based sites, you'll be denied access. You can change this to allow using HTTP access allow all, and this would match all IP addresses on all subnets that go through this proxy server. There is an allow, however, if localhost access is attempted. Let's see what localhost means. If we scroll up, we'll see where the ACL is defined for localhost. We can do so using Control-Y to go up or Control-V to go down. But since we're already moving up with the arrow key, we'll just find where localhost gets defined. Here we see that localhost is defined to mean all source, or the source IP address in this case, 01, all 255s. And below, we see that localhost is permitted access through the proxy server. So if you are connecting through your proxy server to a local web resource, Squid will not prevent you from connecting. However, if you are connecting through the proxy server using a routable address, you'll be denied because you'll be lumped into the group all. Also notice that the rule allow comes before deny. So if you are connecting from localhost, you'll be allowed. But if you do not match localhost, you'll be trapped by this rule. So to permit access for our local subnet, we'll indicate HTTP access. And let's just include that this is to permit access through proxy server by members of our local subnet 750/24. And this is our rule, which we can reference at some other point. So HTTP access allow, and we should define the group perhaps as local net or local subnet or internal net or some useful name. We're going to define it right here as the following: ACL LAN users, this will be our name, with any source 192, and this is a type supported by Squid, source that is, destination is another type, DST, 168.75.0/24. So this is a definition of a source block. We'll allow access via that source block. So we'll allow it using the name LAN users. This will permit access. Otherwise, access will be denied through the Squid proxy server. We'll go ahead and save the changes. We'll need to restart Squid. And barring no configuration errors, Squid will restart and be back up and running momentarily. Now let's try to access an external resource again, or let's begin with an internal resource, the repository at 100, and there you see it comes up. There's really no indication that Squid has served this information. It's all apparently transparently done, but it's quick, and as a consequence we don't see the traces. So basically locally we are logged onto this system and we are using the VMware instance of Red Hat Enterprise running on this remote system to connect to resources, or in this case a resource on this system. So we're going from this box to this box to get to this box. Now we'll go from this box to this box to get to a web box. Let's try to hit, let's say, our website through the proxy, and this is being proxy served. We can confirm that this is being proxy served by examining the contents of the logs. We did mention that the logs are stored beneath var log squid. So if we take a look, we'll see that there are multiple files. Whenever you access a website or a resource that Squid's able to serve, Squid stores that information in access.log, similar to the way Apache stores access through its access log. So if we tail access log, we'll see requests that are made from internal hosts through the proxy server. By virtue of connecting to linuxcbt.com, we see the hits or misses. The misses, that is, are non-cache hits, meaning if you see a TCP miss, that means the item wasn't in the cache. So Squid had to connect to the server to connect to the public server, that is, or to the actual target server, destination server, to get the file of interest. And whenever you see a hit, that means it was in the cache. But in any event, the local client browser used, in all cases, the proxy server, we see the source being .10, to get to the target, linuxcbt.com, various items including Google Analytics, images, JavaScript to load the menus, you name it. We are going through the proxy server. And there are various files like the store.log, which reveals items that are in the store. By the store we mean in the Squid cache. And there's timing information and errors related to those items in the cache. 200 errors or 200 related messages are usually good, meaning they're in the cache. 300 usually mean, or 300 or 30x usually means redirect related items, and those are usually not in the cache and need to be loaded each and every time. So the files that are here, access log, cache log, store.log, maintain useful information. Squid.out tells you the last time Squid started, the fact that it created the directories that it uses to conduct its business. Again, for